Hello, everybody, and welcome back. Root Beer here on question number 9 for our 2016 Euclid Math Contest. The string AAABBBAABB is a string of 10 letters, each of which is A or B, that does not include the consecutive letters ABBA, or ABBA. I wonder if somebody was listening to music when they were making this question. The string AAABBA, ooh, there's an ABBA, BBAAABB is a string of 10 letters, each of which is A or B, that does include the consecutive letters ABBA. Determine with justification, well, of course justification, there's a written question here, the total number of strings of 10 letters, each of which is A or B, that does not include the consecutive letters A, B, doesn't include ABBA, is what we're looking for here. Okay, so 10 letters isn't that long. There's a couple of things I can think to maybe do. Because ABBA's 4 letters, 10 letters is long. You could at most fit 3 ABBAs in a string of 10 characters. So you might try and do some sort of counting based on the position of ABBAs and how many ABBAs you've got. It sounds a bit messy to me. What I'm going to try and do, it's similar to a Kaylee contest question I recorded a little while ago, where they were talking about strings of, they were inventing a new language with vowels and something like that. I'm going to build the characters, the strings of 10 letters that they want from scratch. I'm going to build them up from scratch using A's and B's. And I think this might be a good approach. Because there's only 10 letters. If they were asking me for, 50 letters long with ABBA, I'd probably have to think of something else. But I think we could probably just say something like, oops, get rid of the last question there. I think we could probably do, okay, so let's let, I'm going to say, let PN, because it's got to be A, B, B, A. So I'm going to set it up nicely, and then I'll explain what I'm going to do. So I'm going to let PN be the number of N letter words, or I think they called them strings, that end in A. Okay, I'm going to let QN be the number of, again, N letter strings that end in AB. RN is going to be the number of N letters, or N letter strings that end in ABB. Okay, so we're slowly building it up, and I'm just going to let SN be the others. I'll say N letter strings that don't contain ABBA. And so SN will be the number of N letter strings that don't end in one of these. So A, AB, or ABB. Okay, and I'm going to specifically say these are the ones that don't contain ABBA. So, first you want to convince yourself that, okay, P10 should be the number of 10 letter strings that don't contain ABBA that end in an A. QN should be the number of 10 letter Q10 should be the number of 10 letter strings that end in AB and don't contain an ABBA, or any ABBAs. RN, or R10 will be the number of 10 letters that end in ABB, and SN, the number of 10 letter ones that don't have ABBA that end any other way. And so if I added all of those up, I should get the desired number that they want. So that's something to point out. There's no overlap. There's nothing that could end in an A that also somehow ends in an AB or also ends in an ABB. So we're fine. We're not going to be double counting anything. Okay, so we'll make a little comment here. P10 plus Q10 plus R10 plus S10 is the desired number. Okay, and now I'm going to sort of make a little chart here. Not enough space there. So we'll put the PNs here, the QNs here. I'll put N up here, RN, SN. So if N is 1, we're just going to build these up. We're going to get all the 1s, and then what we're going to do is we're going to add on either an A or a B to the end and get the ones of length 2. So PN, well, if you are just an A, just A is 1, a thing that ends in A. So it's a P1 is 1. There are no one-letter strings that end in AB or ABB, but B is something that we do need to consider. It's another string. It doesn't have ABBA in it. Okay. Now, the two-letter strings that end in A. Well, you could take either of these, either of the previous two, and add an A to the end. So there's going to be two of them, the sum of this one and this one. In fact, any of the previous ones, just add on an A to the end and it goes up into this category. Right? Yeah. Well, eventually, no, we won't want to add on the RNs because that would make an ABBA, but I'm thinking too far ahead. Basically, if you add an A to the end of A or B, you get one that ends in an A and also doesn't contain ABBA. QN, if I took this A and added a B to the end of it, I would get something that ends in AB. And so that's AB. What's the other string? Well, if we took this B and added a B to it, it doesn't end in A, AB, or ABB, so it goes here. There's nothing here. How about strings of length 3? Well, we could take each of these ones that ends in an A and add an A onto it. We could take each one of these ones that end AB and add an A onto it. We could take each one of these that is normal and add an A onto it, and it won't make an ABBA. So all four of these, we get 4 new letters, or 4 new words of length 3 that end in A. So you get AAA, ABA, BAA, and BBA. So there are indeed 4 that end with A there. Once again, if I took any of the ones that previously ended with an A and added a B onto them, then they'd end in AB. And if I take anything that ended with AB and add a B onto it, you'll get a 1. You'll get a 1 down here for RN, and that'll end in ABB. Okay? What about the other ones? Well, if I take any of these and put a B on the end of them, well, then it doesn't end in ABB, AB, or A, so it's just some other thing and it doesn't have an ABBA. Okay? So there's 8. And if we look at the 8 possible strings, we have split them up in just the right way. Okay, so there's the 1 down there for SN. There's these 4 for PN, this 1 for RN, and these 2 for QN. So this is slowly working, but now, when I try and make strings of length 4, again, take any of these and add an A onto them. So any of these, add an A onto them, and you're fine. But if I try and add an A onto the end of this one in the RN, then I would get an ABBA, and we're trying to avoid ABBA. So these 3 all go here and put a 7 here. And so we're starting to learn rules on how we make these numbers. Anything here just goes over here. Anything here just goes over here. And, well, if you add on an A to any number, it has to end up here. So This is done by adding b's, this is done by adding b's, and if we added b's to either of these, you'll get a, so this would go to a, b, 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 and this would be anything else that ends in a b, so these two give you your final numbers. And if we wanted to, we could double check those, check all, 16 possible strings. And I think I'll do that, just to make sure that what we've got is right. So I'll just list out all 16 possible strings. I won't look at my predicted numbers, just to make sure. Now, if you're confident in what you're doing, and you're doing something similar, then you should be fine. You won't need to check this. But I've got the time, and I want to show you, yeah, you should check your answers if you can. So there's that ABBA. There's going to be one number that we don't include, or one string that we don't include. Now I got to do the ones that start with B. B A A A A, B A A B, B A B A, B A B B, B B A A, B B A B, B B B A, and B B B B. Okay, so we don't want to count anything that has an ABBA. How about ones that end in A? 1, 2, 3, 4, 5, 6, 7. Exactly as predicted. Alright, what about things that end in AB? 1, 2, 3, 4. Exactly as predicted. How about things that end in ABB? 1, 2. Exactly as predicted. And we'll use purple for the last one. Anything else that it doesn't have an ABBA in it? 1, 2, and we're done. Okay. So, we can explain these rules, or we can, show them off, or something like that. The next Pn will be the sum of everything except Rn. And you could probably explain, you say, don't include Rn as it means da-da-da-da-da ABB plus an A. And that's not allowed, because then you'd get an ABBA. Alright, Pn plus 1 is just... sorry, not Pn. Qn plus 1 is just the Pn's. If it ends in A, you add on a B. Rn plus 1 is just Qn. If it ends in AB, so it must be in the Qn's, you just add on a B. And Sn plus 1 is... you can't add on an A, so you must be... otherwise, it would go into the Pn plus 1 category, so it must add a B, but not to anything in Pn or Qn. So it's just, you take anything in Rn, add on a B, or take anything in Sn and add on a B. Okay, so that should work. So the SNs are just strings, it ends in too many Bs, almost, to be useful for ABBAs. But now that I've got that relationship, well, I can make this chart a lot faster. N, not 0, we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And as I already said, at the end, you're going to want the sum of exactly these numbers. So we'll just add up the last column, and then we should be done. We've explained our recursion. Now it's up to us to work these out. So I got my calculator beside me in case I need it for some of the bigger calculations, just to go faster. Alright, the next Pn. So P2 is the sum of everything except the Rn's, so that's going to be 2. Already saw that. You basically copy these two rows come down here, so I already know the next two will be 2, 1 here. And then these two add up to be 1. These two add up to be 1. And then these 3 add up to be 4, and then you copy. And these two are going to go to 2, and we got a 7 here. So now 7, 4, and this 2 give me a 13. So if we wanted to, we could really double check. I'm not going to waste our time like that. This becomes a 7, this becomes a 4, and these two turn into a 4. Oh, it looks like these two will be 8. But I think that's where the similarity is going to stop. 13, 7, and 4, so there's 24 of length 6 that end in an A that don't have any ABBAs in them. 13 here, 7 here. So now this turns into a 15. This becomes a 13, this becomes a 24. 8 and 13 is 21, plus 24 is 45. Put a 45 here, put a 24 here, put a 28 here, and then what are we going to have? 45, 24, and 15. Is 84. Copy the 84 down here, the 45 down here, 24 and 28, 52. 84 plus 45 plus 28 is 157. Copy the 157 here, the 84 here. 45 and 52 is 97. And then 157 plus 84 plus 52 is 293. And now if I take those in total, P10, Q10, R10, and S10, that should be 293 plus 157 plus 84 plus 97. So let's add that up. 157, 84, 97. And we get a total of 631. Oops. 631. There we go. So I think that's a nice way to do the question, just sort of building things up recursively. You can do this if you're willing to put in the effort with just about any sort of length of string. If you've got a particular segment you want to avoid, here we're trying to avoid ABBA, but you could do it with longer things with more characters. It just requires a lot of work, but there's this nice recursion to this. I think these are what these sort of words are something called regular expressions. Off the top of my head, I don't know. But let's get back into it because we're only halfway done the question. That was A part, but we do have a B part here. In the diagram, ABCD is a square. Points E and F are chosen on AC so that EDF is 45 degrees. Just like, since it's a square, this will be 45 degrees, and so will this. If AE is X, EF is Y, and FC is Z, prove that Y squared is equal to X squared plus Z squared. Interesting. This is a nice little Pythagorean relationship. I don't know many angles. Obviously this is 45 and down here is 45, but I don't really have a handle on any other angles. So, I don't think we can trig our way to an answer. There might be, I might take that back in a moment, but just, there seems to be too few angles, too little knowledge about X, Y. I mean, we're just told, okay, it's broken up into X, Y, and Z, and you've got a 45-degree angle. It seems like that's too little information to be chasing things around with sine laws and cosine laws. I may eat my words in 5-10 minutes or so, but what I like about this, it's Y squared is X squared plus Z squared. And that means that I could make a right angle triangle with them. And what have we got? Well, we've got a right angle triangle in there with X, Y, and Z along the diagonal. So I'm wondering, here, you can stop looking at my face, you can start looking at the question yourself. I'm wondering if there is a way to make a triangle with Y as the hypotenuse, X and Z around a right angle. So I'm going to draw this picture over here. I don't have a whole lot of space here, but maybe some sort of reflection or something can help me. And it's very odd. It has to be related to the fact there's a 45 here. But there are also 45s here and here. And here's X, here's Z, here's Y. Now they are connected here, but they're all on a straight line, and I wouldn't like that. I'd like to, be able to do some construction like drop a perpendicular, maybe turn this into X and this into Z, or something like that if there's some sort of reflection there. I don't know whether or not that's possible. That's something to think about. But I mean, how can I guarantee that would, I would need to be able to show that this is a right angle triangle if X was here and Z was here. So what would I need to do? I'd need to sort of reflect Z around here and reflect X around here. So they called this E, and I think they called this F. Or maybe this might not be X. Maybe there's some way to pivot Z and move Z through space so it lines up like this. And rotate the X around so it lines up like this. You wouldn't be rotating around F there, though. What is it? I think this is A. I think this is B, C, and D. Let's just double check. Yeah, D is down there. Okay. But if that's the case, how would I use this 45 here? Oh, you know what we could do? Yeah. Okay, so if I take CD and I rotate it, and I guess I'll just rotate this whole triangle up here, I can put the Z next to the X. And then since this is 45 and this is 45, together we've got a 90 degree. Which would mean that if the relationship they're telling me is true, then this length has to be Y. It would just be up to us to now show it. So, okay, I think I'm onto something there. So, got to write this up because it is a written question. So let's say, rotate triangle FCD 90 degrees about D. So C coincides with A, and F is now at, I don't know, let's call it G. Okay. Then angle GAD is equal to angle FCD, which is 45 degrees. So, we'll squeeze it in down here. GAE is GAD plus DAE, which is 45 degrees plus 45 degrees, which is 90 degrees. And so I claim, although I'm not sure how I'm going to prove this yet, I claim EG is Y. Alright. It's got to be Y because they want me to show x squared plus z squared is... x squared plus z squared is y squared. And so this here is a right angle triangle. We just finished showing that. But why would this be Y? Oh, well, this line is the same as this line, and this, I mean, it's got that length in common. Can I do, if I show the angles, if I can show that this is 45 degrees as well, then I've got side angle side symmetry, and so GDE would be the same as FDE. And then GE would have to be the same as FE, which we already know is Y. Okay. So what are we going to do? Since we rotated triangle F, what did I call it? FCD by 90 degrees around D, we can see that, I'll use purple, this purple line must have moved 90 degrees in space. Because this is 45, 45 is half of 90, that makes this 45. So G, D, new position of F to the point it rotated around to the old position of F must be the angle you rotated it by. So we are told EDF is 45 degrees. So let's say EGF, no, EDG. EDG, we'll split it that way. Must be 90 degrees minus 45 degrees, which is 45 degrees. So, what do we say here? ED is common to triangle GED and triangle FED. And by, let's say, construction, FD in length is equal to GD in length. So by side angle side similarity, actually congruence, it's angle 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 similarity, everything else is congruence. Triangle GED is congruent, not similar, congruent, and that's stronger. So EG in length is the same as EF in length, but that's equal to Y. Therefore, it was GAE is right-angled with sides XZ and hypotenuse Y. So by Pythagoras, x squared plus z squared equals y squared, as desired. So we did it by geometry. I would be curious to see if you started naming angles in here, if you could do it a trig way. If somebody out there has a way to do it with trigs and cosine law, I'd be very curious if you want to leave sort of a sketch, a proof sketch, down in the description below. I think I'm going to move on to question 10 now, but it's a nice question. I like the rotation. Rotation sometimes helps with things. I remember there was a really good question a few years back inside an equilateral triangle, and you had to rotate all the pieces out. It was really cool. This looks good too. It works quite nicely. But there we go. That's all of question 9, both A and B, very different parts. But up next will be question number 10, and we're going to finish off our Euclid paper. I will see you for that then. Until then, keep enjoying math contests, and I'll see you around. Have a great day.